Okay, let's take a look at electrolysis of aqueous solutions. So we'll start by looking at the electrolysis of H2O. Pure water has a very low electrical conductivity because, as we know from the acids and bases topic, pure water ionizes, but it ionizes very little. Okay, so what do? Is we add NaOH, sodium hydroxide, to increase the conductivity, and what that does, it puts Na plus and OH negative ions into solution. Okay, so that means in an aqueous solution we have three ions. We have the Na plus, that's from the sodium hydroxide. We have the H plus, that's from the ionization of pure water. And we have the OH negative, that's from the ionization of water and also from the sodium hydroxide. Okay, so what happens at the cathode? Now the cathode is negative, so you should know that we have two positive ions, don't we, from the previous slide. We've got Na plus and H plus. So which one is going to be reduced? Okay, if you remember, reduction happens at the cathode. If you look at the electrode potential values for sodium and for hydrogen, okay, you'll see that hydrogen has the more positive electrode potential, so it's going to be reduced. So that means at the cathode, the hydrogen ions are reduced by gaining electrons, and that will give us hydrogen gas. Okay. Now what's going to happen at the anode? Well, at the anode we only have one negative ion, don't we? OH negative. So you're going to get this reaction here. So 4OH negative, and it makes 2H2O plus O2 plus 4E negative. Okay, so you can see that we're going to have two gases produced. At the cathode we'll have hydrogen, at the anode we'll have oxygen. And the overall equation is 2H2O gives you 2H2 and O2. Okay? So some general points. Colorless gas evolved at the anode, oxygen, and the cathode, hydrogen. The ratio of hydrogen to oxygen is 2 to 1, and you can see that from the previous equation. The pH at the anode decreases because the OH negative is being discharged. Okay, so that means the pH will decrease. The pH at the cathode increases because at the cathode you have H plus being reduced to hydrogen gas. Okay. Right, let's take a look at electrolysis of NaCl, AQ. Sodium chloride solution, AQ, is also known as brine solution. Electrolysis of brine produces chlorine gas, hydrogen gas, and sodium hydroxide. All these products here have a commercial value. Okay? So what are the ions present? Well, now we have Na plus, Cl negative, H plus, and OH negative. So what you have to decide is which ion will be discharged. Okay, so we'll start with the cathode again. The cathode is negative, so we have Na plus and we have H plus, the two positive ions. So again, for the same reasons as before, Na plus and H plus accumulate at the negative electrode, and as we mentioned before, H plus is reduced because it has the more positive E value, electropotential value. So that means we get this again, same equation as before. Okay, so that means we get hydrogen gas evolved at the cathode. Now, at the anode, it's a little bit more complicated. You get Cl negative and OH negative, they both accumulate. They're both attracted to this positive electrode, aren't they? So, at low concentration of sodium chloride solution, that's less than 25% by mass. Okay, less than 25% by mass. What you have is this. Again, you have the hydroxide ion, the OH negative, is discharged and you get oxygen gas produced. Okay? But if you use a high concentration, greater than 25% by mass, you get chlorine, Cl negative, chloride ions being discharged to give you chlorine gas. Okay? So because we want chlorine gas, it's used to make bleach, we use a concentrated solution. Okay? So you have to know at low concentration you get O2, at high concentration you get Cl2. So therefore we use a concentrated solution of sodium chloride. Okay, what would we see at the electrodes? We'd see a gas evolved at the anode and the cathode. One of those gases would be Cl2, chlorine, and you can identify it by a strong smell. You've all smelled a swimming pool. That's the chlorine smell. And blue litmus paper changes to a red color. The pH increases because the H plus is decreasing. Okay. Right. The last one is electrolysis of copper sulfate, CuSO4. Now, when we look at this example, okay, we have to look at the different electrodes we can use. So we'll start by looking at the ions. We have Cu2 plus, H plus, OH negative, and the sulfate ion SO4 2 negative. So these are the ions we have in solution. Okay, so using carbon or graphite electrodes. At the cathode, Cu2 plus is going to be discharged. Why? Because it has a more positive electrode potential than hydrogen. Okay? So we'll get copper metal at the cathode. At the anode, we get oxygen gas again. Okay? So that's with carbon or graphite electrodes. What will you see at the electrodes? The cathode will change to a pinky brown color. If you've ever seen copper, it's kind of a pinky brown color. So copper is deposited on the cathode, so it changes color. A colorless gas, oxygen, is evolved at the anode. pH decreases because OH is being discharged. And important point here, the blue color decreases. Okay, so we're losing, if you like, we're losing Cu2 plus ions, and they are the reason why the solution is blue. So the blue color will fade. It'll start off a strong blue and it'll become lighter. Okay, so next let's look at using copper electrodes. At the cathode, we have the Cu2 plus ions being reduced to give us copper metal. At the anode, we have copper being oxidized to give us Cu2 plus ions. Okay. What would you see? Well, the cathode, it would change to a pinky brown color. Well, it would already be a pinky brown color, but I guess you'll see more copper being deposited. The anode would disintegrate because what you're getting is the Cu metal, the copper metal, is forming ions in solution. So eventually your copper anode will become ions in solution, and therefore it will be used up. No change in pH and no change in the blue color because the concentration of the H plus remains constant. Okay, so finally the factors that influence selective discharge. That's what we just looked at. Okay, which ion will be discharged? That's called selective discharge. So the three factors are the relative standard electrode potential values of the ions, and that's important for things like if you have Na plus and H plus. Okay, the relative concentrations, so we looked at, say, using a dilute or a concentrated solution of NaCl, and the nature of the electrodes. So for example, if you use carbon electrodes or you use copper electrodes. And that's it.